Here are the notes for section 11.2. It's the area formula for a rhombus, a parallelogram, and a triangle. Let's get started. We know that the area formula for a rectangle is base times height. Remember that the height of that rectangle is always going to be the perpendicular height to the base. And that's what we're going to show here. So we're going to write in here that it's going to be base times height. And what we're going to do is that we're going to draw a triangle on the left side, and we're going to cut off the same triangle on the right side. Essentially, we're just moving it over to show that it forms a rectangle. Cutting that off right there. And so the bottom is still going to be our base, and the height is the perpendicular height. Now we're going to do the area formula for a triangle. We will find that the area formula is 1/2 base times height. Again, we come back to base times height, and you'll see this over and over again that we come back to base times height. What we're going to do is we're going to take this first triangle. This is going to be the height. This is going to be the base. And we're going to make a square out of it. And what we'll find is that we know the area formula for a square is base times height, but we're just going to take half of that. The next part is we're going to take this triangle and drop in the altitude. We have the height, the perpendicular height, and the base, and we're going to form a rectangle around it. So we have two congruent rectangles, and again, we're just going to take half of each rectangle. So once again, we have 1/2 base times height. Go ahead and try and do the bottom yourself and see if you get the rectangle. All right, so this is what your triangles should look like. On to the kites and rhombus. So what we're going to do is we're going to draw a rectangle around this kite. And what we're going to find is that the base and the height of this rectangle is going to be the same as the diagonals of this kite. So there's the height, there's the base. And so again, we take it base times height. We keep coming back to that. And what we find is that each of these boxes, we're taking half of it. So we're going to cut out half of each one of these rectangles. So we're going to call it D1 and D2 for the diagonals. And so our area formula is going to be 1/2 D1 times D2. Now stop the tape and go ahead and do these examples yourself. Okay, let's go through the answers for this. An equilateral triangle, all the sides are going to be 6, and all the angles are 60 degrees. So we're going to drop in an altitude, which is also going to be the height of the triangle, which breaks up the base into 2 parts, 3 and 3. So we have a 30, 60, 90 degree triangle, so that means the height is going to be 3 square root of 3. So solving for the area formula, it's going to be 1/2 times 6 times 3 square root of 3. Please don't make the mistake a lot of students make where they use 3 rather than, or they use 3 rather than the whole base of 6. Yep. So our answer is going to be 9 square root of 3 centimeters squared. Next one, an isosceles right triangle, the hypotenuse is 3. So using our 45, 45, 90 degree triangle, the base and the height are both going to be the same, isosceles right triangle, 3 square root of 2 over 2. So multiply it together, area is equal to 1/2, the base times the height. But I'm going to write down 3 square root of 2 over 2 squared, since they're exactly the same. But you could multiply it all out. You could write it out. And we get the answer to be 9/4. Let's do the area of a rhombus. The diagonals are going to be the square root of 8 and 3 square root of 2. I know that the diagonals bisect each other, but we're writing it as if the whole diagonal is going to be the square root of 8 and 3 square root of 2. So we just use the area formula. 1/2 diagonal 1 times diagonal 2. 1/2 times 3 square root of 2 times the square root of 8. And our answer is 6. The next one, we have a rectangle that is inscribed in a circle. That means it's inside the circle. All the vertices touch the edge of the circle. We have one side that is 10, and we have the radius is 13. We're going to extend that radius across the circle where it's the diameter of the circle. It's also going to be the diagonal of that rectangle. And so the diagonal turns out to be 26. One side is 10. Using the Pythagorean theorem, the other side is going to be 24. And yes, this is not drawn to scale, but it's no big deal. Finding the area is just going to be base times height, 10 times 24, which is 240. And that is inches squared. Remember to bring your notes to class, and the magic word to write down is pyramid.